In this video, y'all are going to learn how to protect a net application with byte height shield. First, let us explain the structure. Let us say we have the application of a supercalculator. This solution can have different projects. For example, the graphical interface or the console, the core, and it could have many more, like integrations, helpers, extensions, and everything necessary for this project to work. What we are going to do is demonstrate how we can safeguard all the projects that fall under this solution, or choose which ones we wish to protect and which ones we do not. And we can also establish various protections for each of them to adjust the level of protection depending on their respective importance and requirements. So, what's the first thing we got to do? The first thing we need to do is create an account on byte height. If we don't have an account, we can create one for free, and we will access our control panel. In our control panel, what we are going to do is create a project. It is important to differentiate the projects however you want. In the end, a project is like a container, sort of like a solution, where you have various applications. In this case, you're creating an application. For me, even though we have different Visual Studio projects here, the application is just one, because in the end, these are components of the application. So I am going to create my supercalculator application. Let us provide it with a brief description so that we can understand what it is all about. And I am going to opt for .NET as the programming language. Shield automatically adapts to any version of the language it is used with. In other words, it doesn't matter if you're using Net Framework, Standard, Core, Xamarin, or any other type of framework, even Unity. Shield will automatically adjust the settings to work properly with your project. Besides, it doesn't matter the version. It doesn't matter if you're using Net 5, Net 6, Net 7, Net 8. It's going to work for each one of those versions, even the latest one. We'll select the integrations. In this case, what we want to do is protect the source code, so we will select the Shield product. Let's go to the next step. Here we can select the devices. In another video, you can see how teams work, how we manage members of our organization. By default, as soon as you create your account, you'll have an organization with a team called General, including all members by default. Once we have created our project, we can observe that we are now able to directly view it in this location, and we also possess it within Shield. If, for example, we go to Shield, we had another project before, and here we have this project that is the new one we just created. If we click directly on the supercalculator project, it will take us there and select the default project. So, in what way can we ensure the protection of our application directly by utilizing this particular method? Here we can see that we have a project token. It's important that you keep this project token safe. Don't share it because anyone could protect using your account. And if for any reason you have a security issue with the project token, you can come here and generate a new project token by clicking on this button, and the old one will be disabled. How can we directly include this in our Visual Studio and make it work in both Visual Studio and other IDEs, as well as ensure its compatibility with Azure DevOps or any other type of continuous integration platform that we may have in our workflow? Well, the first thing we have to do is go to our project in Visual Studio. And for example, just as an example, we are only going to protect this interface right now. Our next action is to manage the NuGet packages. We must diligently search for the ByteGuide Shield integration. This is a crucial task that demands our focus. Let's prioritize it and guarantee we locate the appropriate package. Once we obtain it, we can proceed with the integration process seamlessly. We will always download the most recent version if we already have it installed. Most likely, if we are not using the most recent version, it will prompt us to update to the most recent one. Click on the Apply button, and once our package is successfully installed, we can see here that the integration is fully installed and ready to use. What we need at this point is the configuration file, which involves two important steps: linking this project to our account and specifying the desired protections we want to utilize for enhanced security. There are multiple ways to do this, and I will show you using different methods, but the easiest approach is by directly utilizing the configurator of our project. For instance, when we search and establish our application from this location, we will have the capability to observe that we possess various alternatives at this place that we can choose in order to configure our application. This is a little workflow that shows how things work and the order in which things happen within our protection process. First of all, we have different presets. Presets are nothing more than pre-established configurations. In other words, if I use the maximum preset, what it will do is automatically add all possible protections for my application. Protections added based on account edition. If all protections present, all will be added. If I possess a lower level account, solely the ones that are accessible in my edition will be included. The same goes for balance and optimization. In the end, maximum will apply everything. The balanced one seeks a perfect balance between security and optimization of your application, and optimization is for applications that are very critical in performance and require excellent optimization. On the other hand, we can select custom, which is what we're going to do in this example. The next thing is that we can choose when we want to protect. For example, we can protect in debug mode, we can protect in release mode, or we can protect always. In this case, I want to protect at any time. Here we have the list of protections. To see the protections, we can also go to the documentation and we will be able to see the list of protections. But to continue with this video, I'm going to show it directly with this visual editor. For instance, let's assume I desire to rename the methods in my application. I also wish to prevent them from debugging my code. I want to modify and safeguard the flow of my application's code. And I am also interested in protecting the constants of my application from being accessed or altered by unauthorized users. In this case, I would have set up these protections in a custom way, because it's me who's saying which protections I want to use. When we see that the protections have a configuration wheel, it means that they have parameters that can be configured for this specific protection. For example, within the renown, there are different options. If I click here, I'll be able to see that I have different selectors to choose which option I want to use. For instance, I am concerned about safeguarding public figures. By default, renaming will not provide protection or alter the names of the public members of your application, because they might be accessed from external sources. However, since I am aware that is not the situation, yes, I do want to set this parameter to true in order for all the methods to be renamed, and various other settings that you can choose from here. Afterward, once we have finished setting up our protections, we have the messages, but we will provide an explanation of the messages in a separate video. They are just notifications we want to receive when the protection process is finished, whether it's been successful or not. This setup, which has already been created, we have two ways to obtain it. On one hand, we can see the code that will directly show us how our configuration would look like, or we can directly download the file. In the end, both forms are valid and we can do it however we want. I'm going to copy the code directly because I want to show it in a more visual way for this video, but it's easier for you to directly download the file and put it in the directory where it's needed. Now let's move on to the explanation of this. After obtaining my application, the configuration files must be placed in the root directory of my project. In other words, if I desire to safeguard the UI with a particular configuration, I must include my configuration file directly at this location. Is it possible to use another config file or copy the same one if I want to use the same options for Supercore, but it's necessary to have a config file in each of the projects I want to protect within my solution? As an illustration, in this specific case, our intention is to create the file. The file needs to be named Shield config, and the extension should be in the JSON format, which stands for JavaScript Object Notation. Upon clicking accept, it will be observed that automatically this configuration file is associated with the user interface. And now we have the ability to directly copy and paste the content of the configuration file that has been generated for us. We can simply grab this from here and effortlessly paste it into our configuration settings without any hassle or complications. One important thing is that the token from our project is automatically being copied for us. We can see that it ends in 301, and if we go into the details of our project, we can see that it ends in 301. Therefore, it is crucial for us to keep in mind that if this token changes, or we update the token or create a new project, we must also update it here, because if we fail to do so, it will not work as intended. And automatically, this token is going to establish a link between all the protections that occur under your project, in the case of the supercalculator. Another crucial piece of information: there exists a parameter referred to as the secret of protection. Ultimately, this is merely a basic password because we will provide an explanation in a separate video on how to accomplish this, but there exists a potential to interpret or decrypt the exceptions and errors that arise in your safeguarded software. However, in order to accomplish this, it is essential to possess a key, which should be known exclusively by you individuals, thereby enabling me to authenticate the encryption and retrieve the initial code of those exceptional cases. Not your complete code, but the exceptions. In this case, you can put a secret key. I'm going to use CLA 321 for this example. Here we see the files, the settings that we have established in our previous workflow. The preset we are using is custom. The default configuration has a name, but it is just so you guys, if you have multiple configurations, know which configuration you are using, for example. And then the run configuration command determines whether it compiles, that is, whether it will be protected when compiled in debug mode, when compiled in release mode, and with the haste disco, we will ensure it is always protected, regardless of the compilation mode. We have the opportunity to establish, for example, right here, the word debug. The protections are a list of the protections that will be utilized in case we are using custom methods or approaches. And the protections always contain the protection identification as the first element, followed by the parameter value. In case we don't have or don't want to configure any parameters within what would be the protection, it's not necessary. The well-known portion that we have established is set to be publicly renamed, so this parameter is being included in the process of renaming, along with each of the safeguards and protections. With this, we will be fully prepared to protect the application. Let's save this file and simply recompile our application to ensure its security. We can also see that here the logs folder has been created because it will set up the application logs for us. Upon analyzing the output, it becomes apparent that Shield has initiated its operation during the compilation process, as can be observed. This indicates that Shield is now actively functioning and carrying out its intended tasks as intended and expected. So this application has already been automatically protected. If we navigate to our panel and refresh the page, we can observe that the configuration no longer appears, but instead the protected application is displayed directly. In this particular case, it is the user interface application. Subsequently, we can view the history here. That is, we are able to see which protections have been utilized by clicking on the actions. Additionally, we can also observe the aspect I was mentioning earlier, which we will provide further explanation on in a separate video, namely, how to deobfuscate an error and understand its root cause. And we can also download the logs that have been generated in this protection, which would be the same logs that we have locally on the device where we have protected it. So at this moment, if we examine this application, we are able to observe that it has been completely safeguarded. In order to accomplish that, we are planning to load the application directly into a decompiler tool, which will enable us to analyze and examine the code in detail. In this particular case, it is the UI console that we are referring to, and in this specific location, which is here, we can clearly see that the application is protected, unlike the original application that simply had a few small methods and a little bit of code without any additional security measures in place to safeguard it from potential threats or unauthorized access. So how can we safeguard this app now then? Well, the procedure should be precisely identical. Yes. For instance, if we haven't installed the package because we installed it directly solely in the console, we can or should also install it here, but we can manage it directly from the global form as well. For example, directly in our solution, we can see the integration and we can see that here it is indeed installed, but in this one here it's not, so the only thing we should do is reinstall it. We would click on apply, and as we mentioned previously, a configuration file is required. In this scenario, if I desire to utilize the identical configuration and the project remains unchanged, due to the fact that we have stated that both projects are within my supercalculator, which is the application we have generated in our panel, then I am able to simply duplicate this file and insert it here as well. If at this moment, for instance, I recompile the whole solution in such a way that both applications are protected, we will be able to observe in the output that both begin to be protected. In this scenario, you all have witnessed that it has been safeguarded, and if at present we were to proceed to our dashboard and make updates, we would be able to observe that our supercalculator project already consists of two applications, specifically the console and the library in this instance. Here we can witness the history of all the times we have protected the library, and here we can witness the history of all the times we have protected the console.